At 11:38 Eastern Standard Time, the Challenger lifted off. 73 seconds into its flight, the shuttle exploded, killing all 7 crew members. Over the years, NASA had built a culture of invulnerability. They had the right stuff, able to solve any problem, #1 in space exploration, and they had accomplished unbelievable successes. As a result, it made it too easy to rationalize away years of warnings from lead engineers regarding the effects of temperature variances on the O-ring joints.
I received a telephone call from a fellow that worked for me. And he said, Al, he says, we were just told that there was a weather forecaster, I believe in Orlando, that was forecasting a cold front in the area of Florida that might drop temperatures as low as 18 degrees Fahrenheit by tomorrow morning. And we're really concerned about whether the O-ring seals and these fuel joints of the solid rocket booster will operate at those temperatures.
Basically, the shuttle launch system is made up of the external fuel tank, the 2 solid rocket boosters, with the shuttle attached to the external fuel tank. The 2 solid rocket boosters are stacked fuel segments connected by joints, each with 2 38-foot O-rings in between. The space shuttle launched like a rocket, but it landed like a glider plane. During a successful mission, the 2 boosters dropped off the shuttle 2 minutes after launch and fell into the ocean. After retrieval, they were used again. The external tank would burn up over the Earth. In Challenger, it was the primary O-ring that failed due to the early morning freeze. The rings froze and were not resilient enough to expand and prevent the seepage. The decision to launch was deeply flawed. Alan McDonald and the engineers on the team had tried to warn them hours earlier.
I want you to get the engineers together and have them make an assessment of their concerns of the cold temperatures on the sealing of those O-ring seals. And I would like them to make a recommendation as what is the lowest, safest temperature to launch that we can tolerate. And I want that decision and recommendation to be made by the Vice President of Engineering, not program management. I felt that that was a thorny technical issue and should be decided on its technical merits only.
Behind the scenes, contractors were struggling with infrastructure and life cycle sustainment management issues. Product and supply support was difficult, since replacement parts were hard to find. This required crews to cannibalize other crafts for spare parts, making maintenance planning insufficient due to backlogs. In addition, there was a severe shortage of manpower. Although testing and evaluation continued, the lines of communication between the engineers and management were not clear. There was a breakdown in viable sustainment processes long before the disaster.
So I called the NASA rep there and arranged for that teleconference that evening. And it was a 3-way teleconference between the engineers in Utah, those of NASA in Alabama, and our management at the Kennedy Space Center in Florida. So it was not surprising to me that after the engineers presented their information, the Vice President of Engineering came on just as I requested and recommended that they do not launch the Challenger below 53 degrees Fahrenheit, which was primarily based on that observation of that flight a year earlier. The NASA management really didn't accept that conclusion and felt that if we're going to change the launch commit criteria, we needed to anchor it in something better than just this qualitative observation. And here was a condition which we had claimed as, in our opinion, going in a direction that may well cause a failure, a very catastrophic failure. Now, I didn't think it was totally unethical that the NASA people questioned how we arrived at that decision and the data we presented. What was unethical is they knew that we had a moral obligation to always prove it was safe. And what they had just done was put the engineering people in a position to prove that it would fail. That's a totally different question. You're never supposed to do that.
What led up to the disaster was a combination of groupthink, severe gaps in system engineering management, a lack of adherence to the core tenets of system design, and poor leadership.